and welcome to our presentation. The topic of our presentation is Road Accident in Canada Explored, and which we call it Project Race. And my partner is Tolu Fatoki, and these are the tasks we are divided between ourselves. And some tasks we did together as a team, and some tasks we did individually. So after that, I'm gonna show you the outline. The outline of our presentation is introduction, solution overview, tools, methodology, limitation, and conclusion. So let's move on to our introduction. So top priority of a country is to keep their roads safe and run their economy properly. But however, in that case, road pollution are not decreasing day by day, though government takes all the necessary steps. In a record in 2015, 47 of road accident occurred in intersection in US. Moreover, in Canada, 42% collision take place in intersection area as well. So, government of Canada took measure to achieve safe road by launching road safe strategy 2025. So keeping this in our head, we set our project topic, and in this scenario our goal is to help environment to achieve this goal by providing a machine learning solution. So in our solution overview, you can see that we have a data source that we is stored in the MongoDB, and this data we're gonna use to create interactive visuals and our machine learning model, which we are gonna show it to the user to our web application. So these are the tools we used. So the base one is Python, and for the data storage we use MongoDB, and for chart we use Chart.js, and HTML, CSS, and JavaScript we use as our front end language. So this is the methodology that we follow during our project. So this is the data analysis life cycle. So we discover the problem, and then prepared it, then plan the model, and after that we build the model, and then we communicate the result, and last we operationalize the solution. So first, discovery. So how can our discovery is how can road accident in Canada be reduced considering the effect of road configuration? So a common question can come to your mind what road configuration is. So here is the list of road configuration that was provided by the government itself. So which are non-intersection at an intersection of an at least two public roadway, intersection with parking lot, railroad, bridge overpass, tunnel, passing or climbing ramp, traffic, express lane, collector lane, transfer lane, etc. So our goal is to use this road configuration and predict one of them using our prediction model. So in this case, we are going to predict one of these places, which will help to determine which configuration we need to focus on, and that comes with the question that how it will help the government. So with the output we can determine which place are important in all of those solutions, which never happen or never be reported. Like we took all the important columns, and which has numerous number of data and patterns, but in different pattern and data we can predict and show those roadway configuration which are vulnerable, and government can take measure on it by adding road signs or signals. For example, if we see that for some random data we get intersections most of the time, so we move stop sign and put signals in there, or our government can make mandatory stop sign on every intersection so that the people will be more cautious about it. So the next step is data preparation. So we got our data from Government of Canada website, and which is a collection of reported accident from 1999 to 2017, and we got it in a CSV format. So this is the visualization of our data. This is basically the frequency of each column, and which represent the how many data we have on each column, and we can see from the data from this visualization is it's huge. So first we were gonna do a model planning. So the for model planning, we use basically random forest, but we had some other options. Like k-nearest neighbors, random forest. But initially, we figured out that our data set is categorical, and more obvious that we have selected our class, which is road configuration from there, and that one is C underscore RCFG, and which defines that our problem is classification problem. So then we plan to take some supervised learning algorithms that we mentioned that I mentioned, random forest, decision tree, and k-nearest neighbor. And and in, and initially we use random forest as our as our uh, model building algorithm, so that we can move forward and compare the others and take the best one from it. So then we come to the model building part. So model building part consists of 4 steps, and which has feature selection, model training, prediction, and evaluation. So to explain this part, I'm gonna move on to my Python notebook and to show you how we did our model building. So initially we load the day, we load all the important and necessary libraries, and then we load the data, and this is the data set originally we had, and it has 67 is more than 6 million data. So then we check the missing data, and we found out the indistinct value of each column, and then we remove all those data which is unnecessary for our model building, and we check that in here we have some data which is in the same column we have some data integer and some data in string. So we needed all the data in integer, so we converted all the data, all the columns into an integer, and then we got this. And after removing all those unnecessary data and make it integer, we have uh, 3 million data right now. And after that, as we mentioned, that most of our columns are categorical, and we found some of them like age is not categorical, so we have to make all of them into categorical, so that it will help to predict and build our machine learning model properly. So that's what I did in here, and and then we separated all the columns in one side and our class feature in other side. So in the feature engineering, the most important part we did is find out which columns are important, and which columns has a better correlation with our class dataset, our class feature. So that's what we found in here, and according to this we remove rest of the column and left these columns for our next step. So then we came to the model training. So I'm gonna go back to my notebook again, and before the training we had to check if there is any if our data is, and our column feature has any overfitted data. So and we checked and we found that it was heavily imbalanced, and for by doing so we had to balance our data and we did the upsampling to balance the data, and after balanced it, we have this amount of data on each item, on each distinct item. So after that, after balancing data, we have now more than 20 million data in our data set. And then we split our data set into training and test. We put 80% in our training and 20% for our testing, and then we build our model using one of these four, random forest or decision tree or k-nearest neighbor. We just put the algorithm in there and we can get the result from it. So next we're gonna go the model prediction. So yeah, here we go. The model prediction is showing that after building the model, it can predict properly or not, and this plot is showing how accurate our model was, because it was basically actual versus predicted plot, and the red one was the truth and the green one was the predicted. So you can see a slide red out from the plot, but most of the cases it's overlapped, and which means our prediction was pretty accurate. And we can see the test accuracy is 98% for this particular uh, algorithm. And confusion matrix looks really nice for it. And then it comes to the model evaluation, and here we go. For this, here we can see the confusion matrix for our different algorithms, and at the end which communicate result, it shows the different algorithms with their training accuracy and test accuracy, and all of them are pretty good and showing promising result. So then it comes to the operationalize. So before I go to, because in this case I'm gonna move to our web application. So before that, I'm gonna show you how we used our model in our web application. So we basically pickle our model out in a .acv file, and we use this .acv file in our web application. So let's move on to our web application. There we go. This is our web application, which basically shows analytical description of the data we have. So for development purpose, we are showing here only 2000 data to 2011 data. And I took this data randomly from our main data set, so that our development process goes in a right direction. So all the data and all these all these plots are showing from the database we have, and the data all the data comes from the MongoDB, where we can see the total collision, average collision, yearly number collision. You can see that if you go yearly, it's showing the number of collision decreasing, and it shows the clear weather causes a more accident than the other tough weathers like snow and rain. And then we move on to the tables, and this is basically where I'm showing all the data we have from the database. It's raw data, so and from here we can download the Excel, so that the whole data we can use for some other purpose or anywhere else, and we also can search it from here. And it's pretty fast and show you the accurate result if you want to if you want to see analyze specific data based on your search criteria. And now I can show you the chart. This is the charts I built using the data. So this is the last year collision. This is a bar chart of month-wise collision distribution. This is the gender ratio. This is age-wise distribution. This is day-wise collision, and this is the collision difference, clear versus by week and rain by week. So after that, the main part that we have is the prediction, and for this we use that SCV file, that model, to predict our roadway configuration on the basis of the data we inputted in this form. So we can go to select any pattern of data from here, and we fill up every item in here, and then we're gonna submit it, and after a while it gonna show a predicted result of roadway configuration, the list I've shown you earlier. It will show one of them as a predicted result, and it's showing that at an intersection of at least two public roadways, which was one of our roadway configuration. So these are the interactive web application that we have for the users, and they can use it anytime. And I can show you one thing: the data we are having is from the Mongo database, and I'm using a client version, Compass, and it's super easy to access. And if you want to add more data in here, it's easy. You can import a file and put it on a CSV. So we can also import the new data that we imported, that we just imported, like in here. We have 2012 data right now. So the new data, we can export it as an Excel, and we can import it again in our database. So import it in database or in any other database to for further process. And we can add any other data in here from other sources through CSV, which is super easy and comfortable for any data analyst. So yep, that's what it's shown. And the limitations, the large data, the main limitation we had that with the large data set, and it was really hard for us to storing and accessing in both Python analysis and web application development. And there is one other thing that we had, that due to this pandemic situation, we couldn't go physically to the stakeholder for necessary meetings. And for the lack of sophisticated machine, for the development process went slower, and our expected result was not that good. So during the machine learning model, so we had to take help from outside to run our model with the full amount of data and execute it with the web application. So finally, predicting road accident at different identified hotspot in Canada, that we actually try to do in here. And our data set was gotten from the government of Canada, and we ultimately build a website where user can interact the different features of data set and the predictive model. And and lastly, all of our project files, codes, and guides will be found in GitHub repository, and which we already included. And thank you very much, everyone, for be patient during my presentation. And do you have any questions? You can ask. Thank you very much.